students. So we are on day 4, and today we're going to start looking at Boyle's law, so our very first gas law. What you will need today is that note sheet that we just started earlier this week, and you'll also need a calculator today, so make sure you have those handy. I would also grab a scrap sheet of paper for something to write on because we are going to do some practice problems. So to get started, your learning target today is to know what Boyle's law is, so hopefully you know a little bit more about Boyle's law than you already do at the end of today's lesson. So, Boyle's law. Boyle's law states that the volume of a gas is inversely related to its pressure. We learned earlier this week that volume is how much space something takes up, and the pressure is how much force is exerted on an object. So Boyle's law is relating the size of something to how much force is exerted on it. Something very important in this definition is this word inversely. We need to know what that term means in order to fully understand this definition. So again, the volume of a gas is inversely related to pressure. What inversely means is it means opposite. So as one increases, the other is going to decrease. As the volume of a gas goes up, the pressure goes down. As the volume goes down, the pressure goes up. So they are like this. As one goes up, the other goes down. They are inversely related. So make sure you have both of those things listed under your definition for Boyle's law. An example or the formula you're going to need to use for Boyle's law is this. So here's just a graphical representation of that same definition I just told you. So that, as you can see, as volume increases this way, pressure decreases. So they're inversely related. As one goes up, the other goes down. The formula you're going to need to know in order to solve problems using Boyle's law is this. P1 V1 equals P2 V2. This looks like a complex formula, but this type of problem is actually quite simple. It's just a plug and chug type of problem, which I'll show you in a moment. So in this equation, we have a couple variables. We have P1 and P2. The P's represent your pressure, and the numbers represent our initial and final. So our pressure 1 is our starting pressure. Our pressure 2 is our ending pressure. And as you can probably guess, the V's represent volume, and it works the same as pressure. So V1 is our initial pressure, our initial volume, our starting volume, and V2 is our final volume. Notice here at the bottom, it says that temperature must be held constant. So nowhere in this equation is temperature listed. You do not need to use temperature when looking at Boyle's law. We're going to use temperature later on in the coming weeks in some more complex laws that we're going to be looking at. So as we move on, it looks like we got to a yellow screen. Remember, anytime you see a yellow screen, that denotes that we're going to go over an example problem. So if you want to revisit this again later, look for the yellow screen in the video. So a sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atm. What will the volume of the gas be at a pressure of 0.987 atm if the temperature remains constant? So let's switch over to our whiteboard to go over this problem together. All right, hopefully you can see this okay. So it tells us in the problem that oxygen has a volume of 150 milliliters when pressure is 0.947. Remember, when we're doing this problem, we're going to use the equation P1 V1 equals P2 V2. Your first step in all of these problems is going to be to list your variables. So when we list our variables, P1, it tells us in our problem that the initial pressure is 0.947 atm. It also tells us that our initial volume, so our V1, is 150 milliliters. Notice that when I'm listing out these variables, I'm also including their units. Make sure you're doing that because your units must be the same. It then tells us that our final pressure, our P2, is 0.987 atm. And it asks us, what is the volume? So that tells us that we don't know the volume. That's going to be what we're looking for. So we've listed all our variables. Our next step is to plug them in. We're going to plug into equation. So when we plug them into the equation, we were again going to use this one, P1V1 equals P2V2. So we will have 0.947 times 150, and parenthesis, equals our P2 value, 0.987 times X, because we don't know what our volume 2 is. I'm going to screw this down a little bit. So now we just need to solve. We need to multiply these two values, and when we do that, we get 142.05 equals 0.987x. We're going to divide on both sides to get x equals 143.9. Now, the last question when doing these equations comes to, what is my unit? So remember, we were looking for volume, and our initial volume was measured in milliliters. That means our final volume is also going to be measured in milliliters. So this is our answer. Remember, you're not required to pay attention to sig figs when doing these problems, so don't worry about that. Just generally keep 1 or 2 decimals. Alrighty, so we're going to go over one more example problem that's just slightly different than the first one. So your next problem that we're going to look at is a balloon contains 7.2 liters of HE. Remember, HE is helium. The pressure is reduced to 2.0 atm and the balloon expands to occupy a volume of 25.1 liters. What was the initial pressure exerted on the balloon? So again, let's go over to our whiteboard. So this question is a little bit different than the previous one. It gives us a little bit of a tricky piece of wording. So because we know we're looking at pressure and volume, we're still going to use our same equation. P1 V1 equals P2 V2. Sorry, that's a really bad glare. I don't know how to fix that. That says V2. Just like before, we are going to list our variables first. When looking at the problem, it tells us that a balloon has a volume of 7.2 liters. So our initial volume is going to be 7.2 liters. It tells us the pressure is reduced to 2.0 atm and expands to volume of 25.1 liters. So it tells us our final volume, or V2, is 25.1 liters. The pressure is where things get slightly confusing. It tells us the pressure is being produced or reduced to 2.0. That word reduce signifies that our P2 is the volume or the pressure given. So our P2 is 2.0 atm. Another indicator that we were given P2 and not P1, in the question it asks us for our initial pressure. So it tells us we're looking for P1, so that will represent our X. Just like before, our next step is to plug in our variables. So we will have 7.2 times X equals 25.1 times 2. We'll solve this to get 50.2 equals 7.2x. We're going to divide by 7.2 on both sides to get a final answer of x equals 6.97. Again, remember we're finding pressure. Our unit for P2 was atm, so our unit for P1 will also be atm, or atmospheric pressure. So that is how you solve both of those two problems. Remember, if you want to view some extra practice problems, extra problems running through examples, visit our extra support document that's listed on the Google Classroom page. So that is all the notes and content I'm going to go over today. For homework today, it's a little bit different. You're going to be looking at some practice problems and doing a little bit of reading. So if you go back to your Google Classroom page, you can see that you have your homework listed below. Here is your homework. When you click that document, it's going to open up this. So this is your homework that's going to be due on Sunday. It looks kind of lengthy, but it's really not too bad. So it tells you your first task is to visit the following website. When you click that website, it's going to bring you to this page. This is called Flexbooks. It's a virtual textbook, and it's pretty handy. There's some importances of how does Boyle's Law relate to weather? What is Boyle's Law? What was the background behind it? And then it goes through an example problem right here. So as it's going through the sample problem, I follow along with this on your notes. Okay, so as you work through the reading online, there's some example problems, some questions to answer along the way. So make sure when you're reading online, you're also following along with this homework page. It asks you some questions as you're reading through this document. Notice in this document, as you get to the bottom, it's not loading right now, but usually there's a video right here. You are going to click that video and watch that and answer some questions on that as well. After finishing the online website, you get to question 2. Part 2 has just 3 example problems, just like the ones we just went over, so make sure you look through those and solve those on your own also. Just like before, it's your choice on whether you want to do your homework directly on this document or do it on a separate sheet of paper and turn it in separately. One more thing I want to mention is if you want extra practice on Boyle's Law, if we go back to that Flexbook website, if you click this View Practice button over here, it'll bring you to an interactive practice game. And there's a bunch more practice problems on there if you're not feeling confident in your work you've done so far. So make sure you give those a look if you want extra practice. Remember, we will be having a quiz over this eventually, so make sure you know how to do this because you will be getting tested on it. So again, that is all your homework for today. Make sure you have that in by May 3rd at midnight, so on Sunday. If you have any questions, please don't hesitate to reach out. I'm always available and here to help you. Also remember, if you haven't yet, please check out the video on the new project for the final project. It's right here, right above. So the video is posted there along with the rubric and expectations for your project. And start to decide on a topic pretty soon because that topic is due on May 8th. Again, let me know if you have any questions. I hope you are all doing well. Have a good day.